Oh, I think we're good. Just one moment. Hello and welcome to today's brand new episode of Corecast. I am your host, Tim.
This is Sahil. Welcome, everybody, to a brand new, exciting episode of Courtcast. A few logistical things before we begin. If you haven't already, do join our Discord channel so you can ask us questions there. And if you're watching on YouTube, where we do this every Tuesday, 5 p.m. Pacific, 8 p.m. Eastern, do ask us questions during the episode and we'll get to them as well. So, Tim, without further ado, let's get to it. So, Tim, this we've been in planning for this episode, we had discussed many of the more speculative things about dark matter, and then also ultimately the question of, which we'll get to during this episode, how dangerous is dark matter to us. Before we start on that journey, can we just summarize for the audience who might be joining this episode for the first time, like 1 to 2 sentences, what dark matter is, high level, and we can defer them to the episodes previous as well for more details?
Yeah, certainly. So basically, the story starts with Einstein's theory of gravity. Einstein's theory tells us, that space and time curves according to mass and energy, and as a result, that causes, the overall structure of our universe. It controls how fast it's expanding, how galaxies move around, and how stars in the galaxy move. And it turns out that if we apply Einstein's equation to study the universe and try to weight the different components of mass and energy, it turns out that what we see, the visible matter, only comprise of a very small fraction of the total mass and energy. It's about 5% of the total energy budget of the universe. The remaining 25%, it comprises what we call dark matter, and the rest is what we call dark energy. And we believe that due to the nature of dark energy, it's probably not ordinary matter. So basically, we believe there exists matter that has mass, that in the universe, controlling the structure of the universe, but yet we cannot see them, we cannot feel them. They are completely invisible to us. That's why we call dark matter. But then they outnumber ordinary matter 1 to 5 ratio. So there's more dark matter than normal matter in the universe. So it's one of the biggest mystery in theoretical particle physics, or just science in general.
Yeah, definitely. It seems like there's a lot of stuff out of it. It kind of reminds me of other domains, such as like biology, where I think a small fraction of DNA is actually protein encoding. But that's a separate thing. So I see a lot of parallels with this in other scientific disciplines as well. So I guess since there's a lot of this stuff, I mean, seems like there's 5 times as much of this stuff energy wise compared to ordinary matter. Would you say that, saying 5 and 25%? The energy budget of the universe?
Yeah, somewhere around that. My numbers might be wrong. Maybe it's 20, 1 to 4 ratio or 1 to 5 ratio. I don't exactly remember, but it's
Okay.
somewhere there. But it's definitely outnumbers ordinary matter.
Yeah. So since it's numbers, I mean, we can, maybe a separate discussion is like, is it clumped together or is it diffuse? But there's a lot of it out there in the universe. So naturally, as us being humans, want to know, like, how does this impact us? Like, is this dangerous to human beings? So I wanted to let this be kind of set the groundwork of this episode. So I guess, like, can we start off maybe with, I mean, you actually pointed me to this book. There's a book written by a Harvard professor about possibly speculating back in 2015 about how dark matter may have led to the end of the dinosaurs. I mean, this actual full-on book, showed me $19 on Amazon. It's an interesting thing under nonfiction, which is also an interesting genre as well. So could you kind of like start off with, like, how is dark matter and the dinosaurs even like connected? It seems like two very separate things, like paleontological and, like, I don't know, cosmological. Like, how are these two things even remotely connected? And then we'll discuss maybe the nuance of, like, is it true, is it not true? Yeah.
Yeah, certainly. And it's very interesting. I think Professor Lisa Randall, she's definitely a well-known physicist at Harvard. And she came up with a very speculative theory. I think has to do with dark disks. We'll talk about what that means. And the idea is that because dark matter, well, okay, the only thing we know for sure about dark matter is that it has gravity, right? But beyond that, we don't know very much about dark matter. Of course, traditionally, at least 50 years ago or so, particle physics adopted this principle called Octum razor. The idea is that a theoretical theory should be as simple as possible. We shouldn't add extra thing for it to explain it, unless it's necessary. But of course, from that paradigm, dark matter physics actually hasn't moved forward very much because we still don't know what dark matter is. We still have not discovered in the lab. So in the recent decade or so, people have moved on to a slightly different paradigm, a more speculative paradigm, to think about things that are maybe not, maybe doesn't fit into the Octum razor realm, but are plausibilities. And it turns out that when you adopt that philosophy, kind of it allows physicists to open up their imaginations. And if you study the physics, it could actually affect, maybe it could have affected the outcome of the dinosaurs.
Huh. I guess I'm still trying to understand like how is like an asteroid hitting the Earth versus like dark matter destroying the dinosaurs? Like how's dark matter destroying the dinosaurs a simpler explanation than like an asteroid coming and wiping out the dinosaurs?
Yeah. So certainly, I don't think anyone will defend that. That's a more almost like a simpler explanation. It is not, but we. So for one thing, we believe that if you go through the normal theory of how dinosaurs get wiped out, it's through an asteroids. We believe it's an accident. Just an asteroid comes in, it just happens, right? It's not, the chance is not zero. Sometimes it
Hmm.
happens, and dinosaurs were already on decline anyway. But anyway, I'm not a paleontologist. Or whatever the relevant field is, I don't know. Okay, I don't know about dinosaurs, right? But in physics, um, one of the things about particle physics is, well, perhaps we can turn accidents into something worthwhile to explain, right? And in order for Lisa Randall to link dark matter to dinosaurs, I mean, it's an elaborate story. I mean, we got to break down a little bit, but it's not obvious at all. It really is not obvious. But it's only through after she postulated some physics model and kind of just go at it blind, study its properties, and then kind of brainstorm a little bit. It turns out that, well, maybe there's a link, although a very thin link, but maybe it's plausible. But it's by no means obvious.
Hmm. I see. I see. Could you further explain like what that link is? I mean, how yeah, just like I mean, how could one even come up with an elaborate story of like dark matter destroying the dinosaurs? Sounds like if they inhale dark matter, it would just destroy their internal organs and like they just like would vanish. Like I'm assuming it's not that.
Yeah, it's definitely not that. So the story is definitely elaborate. Okay, so dark matter we know because there are probably dark matter passing through us right now. If we could just inhale dark matter and die, we all been dead already, right? There would have been no humans, right?
Yeah.
So we know that doesn't happen. And in fact, in the lab, people have vats of material on the ground just waiting for dark matter to hit, and nothing has hit it, you know. And us humans, we're not that different from these vats of stuff on the ground. So if those stuff doesn't get hit by dark matter, we probably won't get hit by dark matter, and so won't the dinosaurs. Dinosaurs probably did not get hit by dark matter. So the
Mhm.
story is elaborate. So what Lisa Randall proposed was a particular type of dark matter that we know one requirement for dark matter is that it has to be diffuse. It cannot be clumpy because it's just because the way the structure of the universe is. So dark matter has to be a little different. It has to be more diffuse. But Lisa Randall considered the possibility that, well, if there are dark forces, you know, our previous episode talked about dark light. That's one of the possibility for dark forces, but there are many. If there exist dark forces, some parts of dark matter could be very clumpy, right? And if dark matter can clump together like ordinary matter, there could be things like dark planets, dark stars, or even what they call a dark galaxy, like a disk-like shape objects. And if that were to happen, that dark disk or the dark Milky Way, could tend to align with our own Milky Way, and so along the solar system, there could be an enhanced density of dark matter, and as a result, Lisa Randall postulated that while with this enhanced amount of matter, because matter has gravity, it could create a higher likelihood for asteroids to periodically, stuff from the asteroid belt periodically get closer to the Earth and enhance the chance that asteroid will hit the Earth. And as a result, maybe that explains, why. Explanation is a strong word. That asteroids get attracted by dark matter and hit the dinosaur and wipe them out. So that's really the long story.
Uh, so are you just saying that there is a chance that, I mean, at least if we follow this train of logic without discussing the veracity of it or what most people believe today, if we just follow the train of logic, it's that essentially dark matter is maybe more dense in our solar system, possibly, and it clumped together such that there's more gravitational attraction to it. And so, like, asteroids kind of coming by would have a higher propensity to come towards our solar system, thus, like, increasing the chances that an asteroid would come, hit Earth, and wipe out the dinosaurs.
Yep, absolutely. Because this sort of thinking, it's only happens recently because traditionally people believe in noctem razor, and we know that dark matter has to be diffuse. It cannot be clumpy. And if
Uh-huh.
dark matter is diffuse, the majority of the dark matter is just in the voids outside of the core of the galaxy. It's all spread out. So even though dark matter outnumbers us 1 to 5 in terms of mass, we probably won't see a lot of dark matter. So as a result, even if dark matter can be dangerous, there just isn't enough of it to do anything. But
Mm.
once you abandon this Ockham razor idea, because we really have no data on the clumpiness of dark matter.
Mm.
We have some actually. Then these crazier possibilities emerges.
Mm.
Although it turns out that if you dig into the literature a little bit, the 2015 proposal has already been Lisa Randall's model has already been disproved
Mm.
recently, although not in 2015. But
Mm.
this is science. I guess you postulate something. It may or may not be true. You probably
Yeah,
don't believe that to be true, and then you see if the data is consistent with data or not.
I see. What about okay, I'm gonna kind of take the side of the dark matter wiping out the dinosaurs for a moment and just play with that. What if, like, I don't know, there was like a giant, because like maybe on average or maybe for the most part dark matter could be diffused, but there might be like very few anomalous clumps of dark matter. What if there was just a huge clump of dark matter, maybe with some ordinary matter in it, that formed this giant asteroid that came and hit the Earth? Is that
That's actually not totally crazy. As
Oh,
recent as
really?
Yes, as recent as 2015, there was a paper on whether dark matter can cause cancer or not. And that's
Huh.
exactly the train of thought they have. They argue that, sure, there's not too much dark matter. And in the lab, we don't see dark matter destroying nuclei, right? So dark matter probably won't cause cancer. But
Mhm.
in your scenario, you can have an exceptional clumps of dark matter, and
Mhm.
you cannot detect it by NASA or whatever because it's totally dark. It just feel
Yeah,
like a Death Star coming in, completely black,
yeah.
coming through the Earth, and as it coincide with the Earth, I mean, but this sort of asteroid collision, it's not the normal asteroid collision that you think. It's not like a massive asteroid come to the Earth and just evaporate the entire atmosphere, right? You have to remember
Yeah.
that dark matter has very, very little interaction with ordinary matter.
Mm.
So when this dark asteroid, if it comes, a small fraction of it will tickle us a little bit. Maybe although tickle is a probably stronger than tickle. It can cause radiative damage. It can knock the electrons or the protons off their nuclei. It can cause damage to the DNA. And these researchers calculated that look, if something really dense came through, all of a sudden you could get a lot of damage, biological damage on Earth, and it's not in look, it's not totally implausible. Do they, if you ask me, do I really believe in it? Probably not, but it's not totally not, it's not impossible. Let's put it that way.
Wait, so coming back, I mean, there's one thing you mentioned about cancer, but with dinosaurs in particular, um, you're saying that it may not be as far-fetched an idea that like a giant, I don't know, ball of dark matter could come and just strike there. Like I'm talking like really gigantic, like huge.
Yeah. I mean, it could be huge, but keep in mind that
Hmm.
if such a cloud of dark matter were to strike, it's
Hmm.
not going to just instantly destroy everything. Because in order for dark matter to destroy stuff, it has to interact with ordinary matter, and we don't believe that it interact with ordinary matter that much. Although that part you can also argue,
Yeah.
there's also some argument there. But the conventional wisdom is that dark matter is dark; it doesn't interact with us very much, and so because of that, it will just kind of be on top of the Earth, or it turns out it will just pass right through. But as
Uh-huh.
it passes through, it will cause great damage to certain things. That's what might happen.
I see. So now coming back to, you mentioned something interesting, that I mean, there was a paper put out that talks about if dark matter causes cancer. So I guess like, is the train of thought that if you had enough of a clump of dark matter, it can disturb the electrons and protons, maybe gravitationally through gravitational interaction, or
No,
like
no,
how
no.
would,
So gravitational interaction will be. So we can talk about that a little bit later.
yeah.
Chances are an anomaly like that probably won't have too much gravity because remember, gravity is quite weak unless
Right?
the dark matter come is really, really, really dense, which is unlikely. But although we can explore that after this train of thought.
Yeah.
So gravitational effects are not very likely, and even if there's extra gravity, look, come on, we're not going to feel very much, right? It might change the orbits a little bit here and there, but look, it's not going to be catastrophic. What we're talking about is extra radiation, dark radiation, something like the dark light that we talk about. If dark matter has even a small propensity to kick electrons around or kick protons and neutrons around, it could cause damage, basically.
Hmm. That makes sense. That makes sense. So I guess like, I how are people thinking about this? Like, does it actually damage like DNA, or is that something to be concerned about?
Well, personally, I would not be concerned about that, but but even in because look, physicists come up with lots of ideas, and chances are they're wrong. But this has not been completely disproved yet. It's a hypothesis, right?
Mhm.
But even if it was true, uh, what are you going to do about it? You can't stop it. It's dark matter. We can't see it. So there's almost like, oh, what is it? Such is life. There's nothing you can do.
That is very fair. That's very fair. I mean, can't I mean, isn't there like a anti-dark matter force field that we could come up with or something?
I think if you somehow cause the dark matter to annihilate, the damage will be even greater. I think the whole solar system will just get wiped out if
Oh wow.
somehow.
Actually, okay, I have a curious question for you, kind of going a little bit off tangent. If you had a matter particle and an anti-dark matter particle, and they collided together, what do you think would happen?
Yeah, probably stuff will come out. And in fact, this is one of the ways that we can hope to find dark matter. So there are two possibilities. One possibility is that dark matter and anti-dark matter is one and the same. So dark matter is its own antiparticles.
Mm.
So two dark matter when they come together, they'll just annihilate. That's
Mm.
possible, right? And then you can ask, well, how come there's still dark matter left? Why wouldn't they just annihilate each other? Well, remember, in order for two dark matter to meet, they have to meet. Like that chance of them meeting It's not
Yeah.
very high if they're really diffuse. So that's possible. Another possibility is that dark matter, anti-dark matter is different. Yeah. And when they come together, they could annihilate. And once again, the reason they don't annihilate maybe is that they don't meet each other. Or dark matter could be like ordinary matter, that we see more normal dark matter than anti-dark matter. Just
Mhm.
like in our real world, we see more protons than antiprotons in the universe. We see more electron than anti-electron in the universe. Dark matter could have similar what we call asymmetry. So I guess the three different possibilities, right? So these are all plausibilities, yeah. But either way, dark matter annihilation, you know, physicists, we've built telescopes to see, are there things annihilating? Are there flashes of light, flashes of particles that come from different parts in the sky? And we
Mhm.
do look for that.
That that is interesting. I guess like that yeah, that makes sense. I guess those two possibilities seem quite reasonable to me. Um yeah, so I guess we've talked about the dinosaurs, we've talked about cancer. Are there any other like I guess like maybe speculative things that were proposed that might have legs regarding dark matter? Things that
Yeah,
sound kind of initially, but yeah.
in fact, there are many possibilities that have legs. I mean, at the end of the day, I think what people don't realize is that physics, particle physics in particular, is actually a highly creative discipline. You know, physicists speculate all the time on crazy stuff. Most of these crazy ideas, they don't pass scrutiny, right? They don't match up with experimental data. But some of these speculation remain, right? And we can follow your train of thought that what if dark matter can annihilate? Can these annihilation cause disruption, right? So one possibility is that when dark matter come together, they can annihilate. But of course, we in our atmosphere and in the sky, we don't see flashes of radiation coming in. Otherwise,
Mhm.
the whole Earth would have been fried, right? That
Yeah.
does not happen. So it can't annihilate that much, right? Um, but it could be that in objects that are very dense, and for things, for example, neutron star or our sun, the star, like stars generally have way more mass than planets. Because of the gravitational attraction, those stars or neutron stars or whatever, they could attract an extra amount of dark matter.
Mhm.
And when dark matter gather up, they could potentially cause catastrophic damage to those things.
Oh, so when enough dark matter gathers, it can cause catastrophic damage, is what you're saying.
Exactly, because like you said, if you so two possibility, right? When dark matter gathers, you get more and more gravity. So two things. It can either have more gravity or it can annihilate. Like a star, when hydrogen gathers up, the hydrogen can fuse together and it emits light. And when dark matter gathers up, dark matter and dark matter could annihilate and they can light up into stuff. I don't know what that is. That when that happens, that could potentially cause a dramatic explosion. And there
Uh,
were actually papers back in the day saying that if planets were able to gather some of those dark matter, it could actually heat up the planet, perhaps. But that heating up will be near the center of the planet, like the
yeah.
core of the planet. If dark matter gathers up and start annihilating, it could be like a planet in a dark matter hot pot.
Hmm. What I guess what's to say that that won't happen?
Well, so in fact, these physicists did calculations, and I was looking at the literature. There was a paper, I think in the early 200s, by the Berkeley folks, Professor Moriyama and team. They consider this possibility, and when you think about this possibility, you kind of have to go to the most extreme cases, right? So Earth is kind of small, so it doesn't have a lot of mass, so it probably won't gather too much. So the most extreme plausibility is you look at Jupiter. Jupiter is a gas giant, right? It's a lot more massive. So Jupiter will gather a lot more of those dark matter. And if it was true that Jupiter is gathering dark matter and the dark matter is heating the planet up, you would see some anomalous signature for heat from Jupiter, right?
Mm.
So the fact is we don't see that, or we don't see, or at least Jupiter is not glowing, right? Jupiter is not the sun. So there's some upper limit on how much that can be.
Yeah.
So they've studied that, and it turns out that while the fact that Jupiter is not getting heated up means that the Earth probably is not getting heated up. But of course, there still could be some small window where Jupiter could be slightly heated up, but we just are not able to detect it yet. So yeah, so dark matter could be could give you like a planetary hot tub. That's possible.
Only the planet's big enough though, right? If it's not too big, then you
Oh
can't
yeah,
really.
only massive enough. It also wouldn't be a very pleasant hot bath. It would be a bath of radiations and particles, antiparticles. It would be a pretty deadly, hot tub. Although only at the center of the planet, so we'll still be okay probably.
Okay. So this is most likely not happening, or at least not happening perceptibly, because we don't see Jupiter like lightening up like the sun or being, becoming like a sun.
Yeah, it still could happen, but the effect probably is not as dramatic.
Yeah.
For a few reasons, right? Probably Jupiter is not massive enough to gather up so much dark matter, and there's not that much dark matter. Of course, they in those papers they did not consider the possibility of a dark asteroid coming in. But I mean, if you compare, if you combine the two models together, like
Yeah.
dark matter heating things up and dark asteroid, if Jupiter gets hit by a dark asteroid and it gets heat up, uh, that would be pretty catastrophic, I'd imagine.
Oh boy. All right, Tim, I'm gonna leave it to you to make sure that doesn't happen.
I mean, I guess that would be pretty fantastic if it does happen. Like Jupiter probably will light up pretty bright in the sky.
Oh boy. Yeah, so I guess it's actually another interesting question that comes to mind is like, is there any connection between dark matter and the formation of black holes? I remember when I learned a while back that there's a supermassive black hole at the center of either almost every galaxy or every galaxy. I forget which one it is, but they're pretty ubiquitous. So I'm curious, like your thoughts on that, like
Yeah,
dark.
it's definitely a mystery. So the supermassive black holes are very, very large. It's like a few million times the mass of the sun. Typical
Mhm.
black holes, we believe, has the mass roughly, equal to our sun, roughly a little more. And the size of typical black holes is, I think, the size of the Earth, roughly.
Mhm.
But at the center of every galaxy, there are super, super duper massive black holes. I think usually a few millions to billion times the mass of our sun. So these are really large black holes. And it's a bit of a puzzle how they form actually, because remember, dark matter it's pretty diffuse, and they're
Yeah.
not that clumpy, and we don't have that much ordinary matter to really make black holes that large that quickly. So so people have considered maybe if dark matter is a little spicy as in terms of having some extra forces, it could actually help make supermassive black holes.
Yeah, yeah, because I'm curious. Like, typically, when I learn about black holes, the formation of them, it seems like a star, a really, really massive star, relative to the mass of the sun, needs to collapse, and that forms a black hole. But these supermassive black holes are like gigantic, like really ginormous, move stars like they're almost like nothing. So I'm curious, like, I mean, is it possible there could have been a star that big, like even bigger, and then just like collapsed into a black hole of that size?
Yeah, chances are, my personal belief is that these are not really formed by stars collapsing because that process is too slow.
I see.
And remember, it's the distribution of dark matter is densest at the center of the galaxy, and maybe
Hmm.
there's a connection to why. I mean, of course, there's a connection. The the center of the galaxy is very massive. It's also got a supermassive black hole, and also it's got a lot of dark matter. But anyway, it's not crazy to think that, hey, look, dark matter played a role. If that were true, then these black holes maybe did not form because of stars collapsing. Oh, that there actually may be two possibilities. So dark matters could accelerate the collapse of stars into black holes. Like
Mm,
when I was saying earlier, Jupiter, if they gather dark matter up, and dark matter could heat up the surrounding, that's possible.
mm,
But let's say dark matter doesn't heat up the surrounding, but dark matter kind of has a propensity to gather up. What could happen is a really, really heavy star could slowly but surely gather more and more dark matter, and those dark matter, if they're sticky, if they
mm,
if they're clumpy instead of diffuse, they could clump up, and a star it could dark matter itself could help accelerate this gathering of mass,
mm,
and at some point, once it gathers enough dark matter, the star could collapse into black holes.
mm,
If that were to happen, it adds an extra possibility. In the early universe, even before stars were formed, there could have been a lot of hydrogen gas, what whatever you call it, and dark matter together. Dark matter
mm,
themselves could clump together, kind of like a runaway fusion reaction, just clumping, 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 and just straight up form a massive, ginormous. I don't even know if I'll call that star or like just like a massive object that just collapses into a super duper massive black hole. But that will require, but in order for this to happen, dark matter has to be a little sticky, like clay or something. That tends to clump. When that happens, yes, dark matter could really make a big impact in galactic dynamics. Yeah.
yeah, I guess maybe one point I want to kind of belabor a little bit more is what makes you say it's slow for like a star collapsing to form a black hole? Like why is that slow? Or what can you give us like order of magnitude wise? Like how do you know this?
Yeah, but I mean, just think about it. Like, in order for a star to collapse to form a black hole,
Mm,
first it has to burn out because because as the stars shine, it creates light, and light actually gives give an outward expanding pressure to keep the star stable. Yeah,
mm,
and that's why the sun is not just a black hole. As it burns and burns and burns, like it's trying to like the sun is basically a thermonuclear reactor. It's trying to explode at all times, but gravity is keeping it in check.
mm,
So
mhm,
in order for the star to collapse further from gravity, it has to burn off its fuel. And that
mm,
takes, I don't know how many million years. Yeah.
yeah,
And that's just to form one black hole. And also, many stars don't have that much mass to begin with. They don't even form black holes.
yeah.
But then remember, the supermassive black holes have, it's like a million times the mass of the sun. I don't think there's enough time in the universe to really like get that many stars to fall into this black hole. So
Mm,
something's gotta give. Like if you crunch numbers, it's it's not efficient enough. Just the normal way to make black holes.
mhm. Yeah. I I can feel my existential dread coming up from this conversation. Uh yeah, I'm curious I'm curious about like maybe the notion. So if dark matter clumps, does that mean it can't be its own antiparticle?
Uh, yes, that is true. So it cannot annihilate. Yes.
Ah, okay. That yeah, that is interesting. So I recognize we're almost at time. I wanted to give you a chance to leave the audience any parting words. I remember you also mentioned that like even though these things are speculative, this is like what science is about. Maybe you can comment on that as well.
Yeah, and just keep in mind that a lot of the discussion that we've had, they're not one like we did not talk about any one specific dark matter models. These there are actually dozens that we talked about. These are many variety of publications, papers, research that physicists did. The reason why we didn't delve into any particular details is, well, first of all, they're technical, and also it's just to give people a sense that um, like we really don't know what dark matter is, and I think this paradigm shift away from Octum razor is legitimate because in some sense you haven't ruled out many of these possibilities. We shouldn't be biased by our own expectation. I mean, after all, there's more dark matter than ordinary matter. Like, who's to say that our beliefs about what it is correct? Um, and I think through our discussion, I mean, some of these ideas are crazy, kind of crazy. Even in the physics realm, right? Dark matter kills dinosaur. I mean, that sounds like a clickbait article, right? Um,
Yeah.
but it just exemplifies that the plausibilities are there. It's immense. It's just the great unknown. Maybe 100 years from now, we'll have better answers. But this also highlights why it's important to do this research, right? Like, if dark matter really causes cancer, I don't think it's likely, but I mean, shouldn't we find out about it? If there are dark asteroids floating around, I mean, yeah, that's maybe it doesn't give me existential dread, but what dark matter is really is something that keeps you up at night as a scientist. It really is a great mystery.
Yeah. That is interesting. Yeah. Is there anything else you want to add, or is that all?
Well, I guess I'll add a little personal note, and in fact, some of the ideas that we discussed, that dark matter clumps, I've wrote like 2 to 3 papers on it, and this is a very fun topic to write about. And personally, I think that this is what makes particle physics interesting. People
Mhm.
often think physics is so boring. You just plug and chug some equations here and there. But that's not really physics. That's just the grunt work to get to the interesting bit. Physics is really a creative discipline, and who knows? One of these ideas may actually be real life, and real life may really be stranger than fiction. And in order to study the world, you really have to keep an open mind and keep your creative options open. And that's what really physics is about.
Yeah, very, very well said. I also feel like I have that as my personal philosophy about physics as well. But yeah, well, on that note, I want to thank everybody for joining us, and we'll see you all next week.
Yeah, see you all next week. Bye.